this one. How many of you drive a vehicle, whether it's to work, whether it's for leisure? All right, good. Over the last few weeks, few months, few years, when you've driven the vehicle, how many of you have encountered some sort of a cryptic symbol that shows up on the dashboard, like a circle with an exclamation mark, a vehicle with squiggly lanes, a P with a triangle next to it? Anybody encountered anything like that? Show of hands. Yeah, I see some, maybe 10, 15%. And when you see that, how many of you know exactly what that means and whether it's safe to drive the vehicle at that point? Couple hands, right? Now, wouldn't it be great if something like this popped up, but along with that, there was a more detailed explanation of what it is, whether it is safe to drive the vehicle at that point in time, and if it is not safe to drive, where is the nearest dealer? And maybe even take it a step further to get you an appointment at that dealer so you can safely take the vehicle to the dealer and get it serviced. So this is just one of the generative AI use cases that are possible. But today, I am thrilled to be on stage. So I'm Sandeep. I'm thrilled to be on stage. We'll have three of the speakers, Cordell, Paul, and Stephen Ellis, talk about different use cases from a generative AI perspective that Toyota has worked on in terms of driving innovation and enhancing operational efficiency. So these are the four of us. Agenda is going to be pretty straightforward. I'm going to talk about generative AI for automotive and the art of the possible. So kind of paint the broader picture in terms of what is possible with Gen AI in the automotive space. I'll then turn the mic over to Stephen Ellis, who will walk us through Toyota's mobility as well as generative AI vision. And he'll also talk about one use case, which is called as knowledge retention. From there, we will invite Cordell to the stage. He will cover a couple of additional use cases. GearPal and battery brain are the two use cases that he will cover. And then finally, we'll have Paul wrap it up. He will talk about code modernization, mainframe modernization, and also paint a picture of what Toyota envisions the Gen AI future to look like from an automotive perspective. So generative AI for automotive, let's dive a little bit deeper into this. Automotive industry typically spends upwards of $1 billion over several years for new product development. And it's not always that this investment of money pays off. So some of the bets that they make in terms of this innovation sometimes doesn't pan out. So you have a capability like generative AI that's really good at data analysis, that's really good at pattern recognition, that's really good at anomaly detection, that's really good at generating new types of data, synthetic data. If you're able to leverage that, there is the potential to reduce design time, development time by several weeks to several months. And there have been studies that have been done by Forbes and others that show that it's fairly easy to accomplish several weeks and several months of time reduction in the design and development phase. So to paint a picture of generative AI for automotive, this is just a very high-level sampling of the art of the possible. I'm just showing you 4 different domains over here. There's many, many more that we can talk about after the break. But the first one, top left, product design and quality. Gen AI can be used to generate innovative design and styling recommendations. But it's not just that. You can also get the evaluations of those stylings and recommendations from the perspective of vehicle aerodynamics. So if a style that you've generated is a poor evaluation for vehicle aerodynamics, you could scrap it without investing a lot of money into actually going through that styling and taking it through trial runs. Moving to the top right, in vehicle experience, personally, I would love a real-time conversational assistant that's guiding me, that's telling me, answering some of my stupid questions, some of the more interesting questions where these cryptic symbols pop up, and and you have no clue. There was a time when I rented a vehicle, and I just could not find the fuel latch to open it. I thought it might be one of those where you don't need one, but I had to, it was hidden and very close to the fuel. It was very close to the floor mat and was the same color, like both of them were in black. But that took me like a minute or so to figure out. So all those types of questions, if I'm driving, it could give me route guidance in terms of what is the best way to take. And then also, if I'm new to an area, then it could probably give me, touring recommendations in terms of, hey, here are cool places to see, right? Occasionally, vehicles will have some issues, and they would need to be taken to a dealer or a service shop for maintenance. And from that perspective, generative AI can be employed to provide guided troubleshooting steps, to service technicians so that they can go through the guided menu, pick out, specific actions that are recommended, and overall simplify the process for diagnosing, coming up with an accurate diagnosis, and then getting the vehicle repaired. And then the lower left corner, last but not least, autonomous driving. One of the challenges with autonomous driving is what we refer to as edge cases. So these are use cases, or these are scenarios which can happen, but have never happened, and therefore it's difficult to train the models on it. So with edge cases, you can take something that has happened and you can generate synthetic transactions based off of that real data set to introduce these edge elements into the picture to be able to then send that to the model for evaluation and further improve the model. Like I said, this is just a sampling, a very high-level sampling. There are multiple other domains. There is manufacturing, there's supply chain, there's sustainability, there's electric vehicles, there's battery optimization. The list goes on, but you get the idea of, the power of generative AI in automotive. Okay, so what do we from an AWS perspective provide? From an AWS perspective, we meet customers wherever they are on their generative AI journey. So if customers are super savvy, they want to play with the chips, Inferentia, Trainium, GPU chips, they want to play with our network, compute, storage. That's the lower tier. They use tools like SageMaker, but they're able to get full control of the environment. We have a lot of customers that say, hey, don't want anything to do with it, just give us access to some foundation models. That's the middle tier, that's Amazon Bedrock. There are 30+ foundation models that are provided, and they're all made available through a single API. And security is job zero, so a lot of security, a lot of guardrails, filtering content, disallowing certain types of topics from conversations. All of that capability is built into this layer, into the middle layer. And then there are some customers like, don't care about the foundation models, don't care about anything of that. I just want to solve business problems, right? So for them, it's the highest tier through a product called Amazon Q, where you're using that, don't have to worry about any of the heavy lifting for the FMs. You can just start using it to solve your business problems. So anywhere on the stack where the customers are, we're able to assist them on their Gen AI journey. Bedrock, as I mentioned, provides a choice of leading foundation models, all through a single API. There's possibility of model customization with some of the models. This is a decision, of the model provider, whether they would allow you to customize models. Amazon models, like the Titan models, are customizable. Some of the Anthropic models are also customizable. If you do customize a model with your data, you are the only one that has access to it. Your data is not used to train, the original model. So from a security, from a data privacy perspective, all of that is taken care of. One of the big use cases in this is something that we call as retrieval augmented generation. And this is where the model, you augment it with your own data source without having to change the weights of the existing model. And then as you get into complex tasks, you have security, you have agents that can execute those. Multiple approaches to customizing foundation models, the simplest being prompt engineering, moving on through RAG, and then the more complex ones around fine-tuning and continued pre-training. Bedrock, as I said, single API, but also more important over here is you can configure thresholds to filter out harmful content. You can define topics that are allowed. You can disallow certain types of topics, so questions on those topics can never be asked. And you can do this from an organization-wide level. So people are then free to innovate because you've already put these guardrails in place. And then the topmost tier, like I said, is Amazon Q. Here, there are different personas that can benefit from using this. So on the left side, what you see is the business persona. So these are users that probably don't want anything to do with coding, right? So in the first block that you see there, from a business analyst perspective, if you want summarization, content creation, extracting insights, all of that can be accomplished through the Amazon Q for Business product. QuickSight, some of you may have already used QuickSight. It's our analytics and querying tool. That has also now been embedded with generative AI capabilities, so you can understand the data with Gen AI. You can build and refine the visuals. You can do calculations, build out executive summaries, and a variety of different things. Moving to the right, Q for developers. This is across your entire lifecycle, software development lifecycle. So in terms of code generation, unit testing, security scanning, code remediation, code migration, troubleshooting, the entire development lifecycle you can get significant amount of help to be able to speed up your processes. And what you will see is that more and more Amazon products are going to be embedded with the Q type of capabilities. So you have the specialized capabilities that we show in that you see on the right-hand side. So there is Q capabilities in a product called Amazon Connect. Amazon Connect is a product for call centers. So when customers are calling into call centers, that's if Amazon Connect is used, then this can do call recordings, summarizations, identifying calls with negative customer experience, using that for training, a variety of different possibilities with the Amazon Connect product using Q. And same thing with our a new service that we launched a couple of years ago on the supply chain. Q is now embedded into supply chain, so you can run scenarios in terms of cause and effect. What happens if there is a bottleneck over here? How is production going to be affected? What do I need to plan for? And a variety of scenarios. It can also automatically be used to identify anomalies, in terms of how much product is available on hand, et cetera. So over the course of the next few days, you will hear about many more products that are getting embedded with Amazon Q and generative AI capabilities. So when you're comfortable with the product, you just get additional help, more capability, and the ability to do work, with more efficiencies as you start using these products. So that's kind of like the breadth of capabilities that we offer. I am going to turn the mic over to Stephen Ellis, invite him onto the stage, and he'll walk us through Toyota's mobility vision, as well as the Gen AI vision, and walk us through one of the use cases.
Test. All right. So most people have probably heard the idea of the automotive space transferring from a car manufacturing company to a mobility company. And for Toyota, that gives us a unique set of opportunities and challenges. One of the opportunities is the fact that some of the manufacturing processes that most people use as best practices across the world were developed at Toyota. And so we have a wealth of knowledge on being able to set a new paradigm. But with all of the opportunities available in the mobility space, we're not just talking about software in cars, we're also talking about software in multiple different modalities. And that is going to present some unique challenges when it comes to rapidly prototyping and iterating to understand new user use cases and also like new manufacturing use cases that are applied to the enterprise. So to be able to help guide the enterprise through this transformation, our enterprise AI team was established to simultaneously create a center of excellence that would be able to help business users understand capabilities, to quickly understand use cases and prove out whether or not they would work or not work, and then also establish standards. And one of the things that establishment of standards allows us to do is rapidly iterate with multiple teams instead of needing to centralize all of the development and all of the practices into one organization. So our team is a very small, lean, and mighty team that basically goes and tries to collect all the best information and bring it back to the enterprise to say, here are the pieces that we should experiment with today, here are the places we want to move to the future, and do it in a controlled and efficient environment. So one of the things that's very helpful is having partners such as AWS that allow us to then create frameworks around some of these needs to have a safe place to play and a place that is available for experimentation. So using that framework, one of the things that we identified was there was this key gap in knowledge between different team members at different levels of experience as the company is going through this transition between standard OEM manufacturing and then the mobility company perspective. And so there was an idea of creating basically a knowledge retention platform that would allow different team members to put their information in and then have that at scale disseminated across the different new incoming team members and also across different regions with different languages. And one of the most helpful components with the advent of generative AI is that it is very focused on language, and it's focused on language in narrative form. So to be able to utilize that, one of the things that we looked at was, okay, what would be the process of creating this knowledge retention apparatus if we did it with humans, so then we could identify the places where generative AI would actually let us accelerate that. So the basic process would be if we were having humans would sit with the team member or a subject matter expert, they record that information, then they would take documentation that was related to that topic and subject matter, compare the two, and then once they compared the two, validate whether or not the information that the team member understood was relevant from a timeliness perspective. So was it old, was it current, or was it some future innovation that hadn't been discovered yet? And then once you have that, then you create a write-up and then you send that out to the organization and everyone socializes it. So having mapped that out, we realized that we could use some of the generative AI processes and in concert with the team from Amazon to create a system that would do that asynchronously across the organization. And so in implementing that, we were able to work on an architecture that allows you to create the initial context for a RAG-based system. So you upload a document, or you upload a set of documents that basically walk through the idea or the use case. And then the system allows you to run an interview where you are asked questions about the topic, and then you speak to it as if you're doing any other human transfer. It takes that, and then it starts analyzing the document versus the information that you've submitted, and then creates a digital mirror of that for other team members to then ask the same questions to understand the information that was inputted. And using the Amazon services, we're able to do translation that has translation to different languages, but also to be able to do context for the actual transcription. So in certain cases, when we talk to humans, we don't actually add a lot of the context that we kind of just naturally infer. So you may have a half sentence or a word that's an affirmative word, but you don't have the rest of what that was connected to. But using the generative AI system, we can then take the topic, make a suggestion of questions that would actually be part of that subject matter, and then use that to drill down further into the concept and the idea, filling the gaps in the knowledge that needs to be transferred to different team members. The ability for Gen AI to then serve multiple use cases can then be applied so that you don't have to worry about, you don't have to define the question that is right for the specific audience. You can actually use pipelines that you can build through either SageMaker or Amazon Bedrock to then create multiple questions that are for multiple audiences. And then as the user is submitting information through a set of interviews, you can then grab the different chunks that are relevant to that audience and sort them. So that later, when someone comes and asks the chatbot about a specific topic at their level of expertise, it knows how to go and find that information that was generated by a subject matter expert and then relay it back to the user in their perspective and context, as opposed to it being super high level and not being able to be disseminated to people that have different experience levels. A couple of the things that we learned was information going into LLMs, because it works best in narrative form, needs to be structured basically in that question answer pair context so that you can then use it in multiple systems, which that is the advantage for a lot of generative AI, is that you can then, once you have your data set in a way that can be consumed by LLMs, you basically transform it into AI native data, which then will work with multiple models as they come out, since all of them are based on the same transformer architecture. So you can future-proof your further data needs, especially with obtaining knowledge across the entire enterprise, by instead of needing to design for one specific model, one specific LLM, you can then make that data transportable, so that when future models come out, or if you decide to refine your own models or train your own models, you can be working from a unified data set and continue to improve. So some of the places that we see this going in the future is to be able to then do multiple retrievals inside of content such as videos, where you can deep link, and then you can find the specific contextual component of the video tied to the utterance that comes from the user, and then that can be added into other documents, such as diagrams or like visual pieces that then further explain and add context to the topic. And some of those use cases will be covered by my colleagues. I'm going to hand it off to Cordell for GearPal.
All right, test. Good deal. Hello, everyone. I'm Cordell France. I'm going to talk to you today about a couple of our generative AI use cases we have built for vehicle manufacturing at Toyota. The first one of those use cases is GearPal. The whole premise of GearPal is to effectively reduce the mean time to repair for machines that go down on the manufacturing line. So my colleagues who invented this wanted to have a tool that they could use to more quickly triage problems for machines that go down on the powertrain manufacturing line for our Kentucky plant at Toyota. What GearPal effectively does is it gives team members on the manufacturing line the ability to walk up to a machine and ask, why are you broken and how do I fix you? To construct a powertrain, there are hundreds of machines and thousands of parts, hundreds of machines, but each one of these machines has manuals that could be thousands of pages. They'll have a parts inventory list. There are several documents that go into this machine that could basically correlate or correspond to why a machine might be going down or why a machine might have broken down. And when a machine goes down, there are maybe only a handful of experts that might know how to get it back up. The manuals might are in different languages, so you might need a translator. The right person might be on PTO, so it can literally take hours, sometimes days, to get a machine back up. And every hour that a machine is down on the manufacturing line costs Toyota thousands of dollars, if not tens of thousands of dollars or more, depending on how long it's down and which machine is down. And so what we built with GearPal is the ability to co-locate all of these documents for all these machines together into a single database that allows users to search and ask questions about how to get a machine back up and running. So if you look at the diagram on the screen, anyone familiar with RAG or who's built a RAG application will probably not notice anything super exotic. This is a pretty basic high-level architecture, but that's part of the beauty. And a lot of the complexity came in with data ingestion. So with our data ingestion, it took us a few tries to really get it fine-tuned to the way that we needed. Because some of the documents are in different languages, some of the machines were built in Japan, some of them were built in Germany, some were built in the US, and so they all have manuals that correspond to their native languages. And the manuals are all complex, meaning that they have drawings associated with them, they have tables, they have images, they have tables within tables, and so extraction can be a little bit difficult in order to try to actually assimilate knowledge from each of these documents. And so when we first built this ingestion pipeline, we started with one data type and then expanded it to others. We not only were looking at machine manuals, which are PDFs and complex in themselves, but we're looking at Excel data, PowerPoint data, videos, images. We have to transcribe these videos. And so being able to construct this pipeline really pointed to making it data agnostic. And when we first built it, we built it without really any language translation, and we were noticing some high latency. So and going back, we realized that part of the latency was because we were doing, when we would search through the documents, we were searching once through each language. And so we basically have these searches in series that are occurring that contribute to high latency for the users, which is not ideal. So one thing that we did to solve this was we went back and we converted all of our data into English. So normalizing everything to English, created all of our vectors in English, so that we have a common language that can be ingested. And so translation occurred at ingestion, made ingestion a little bit longer, but we found latency went down because we're basically searching one language. And then if we need to translate that back to our Japanese team members or team members that speak a different language, we do that after the query. So a user types a query, they get a response back, and then we can translate that on the fly. So this chatbot application had quite a few intricacies with it, but really the fundamental RAG principles hold true here, and that we were being able to scale this and not going too exotic, relying on the fundamental AWS services really enabled the success of the application. One other thing that contributed to the success of our RAG framework for GearPal was being able to construct a golden set of queries. So in order to make sure that our language model was grounded and it wasn't hallucinating and it was producing the correct responses, we produced a feedback system similar to ChatGPT, where you have like a thumbs up, a thumbs down if the response is good or bad. And this allowed us to work with our pilot users to try to calibrate whether our responses were correct or not. And there are three things that go into a thumbs down or a thumbs up. So if you give the response a thumbs up, it has to give the correct response. But we're also citing documents in our responses. So we not only go and say, here's what I found, but here's where I found it, and here's the exact page or exact tab in the Excel sheet that I found it in. And so the thumbs up constitutes a correct response, a correct document, and a correct page. If all those hold true, then we take that and we can use that as a golden query to fine-tune our large language model and ensure that if we were to adjust our ingestion or if we were to switch large language models in the future, we have a golden data set that we can use to ensure that we're still giving accurate answers to our users. The data agnostic ingestion was something that was a lot harder than we anticipated, but it was I would argue, a majority of the problem in trying to build this application. And it's something we were able to reuse into another application called Battery Brain. So Battery Brain is similar to GearPal, but different in a few ways. Anyone who's worked in manufacturing knows that there is a lot of variables that go into producing a good part. And if you've worked in vehicle manufacturing, you know that the process is even more sensitive because you have chemical processes you're balancing, you have a lot of different materials that need to be assessed for purity, and there are a lot of different things that can go wrong. In addition, the subject matter expertise for batteries that know how to folks who know how to calibrate those processes is becoming, well, I would say the demand is much further than the supply right now. So Toyota has taken it upon themselves to produce training, internal training, to give subject matter expertise in battery manufacturing to other team members. So basically, PhD level chemistry knowledge, battery manufacturing knowledge is being distributed and assimilated to other team members within Toyota so that we give more knowledge and more power to be able to spot and optimize processes as we produce batteries. Now, this is crucial because we're standing up a new manufacturing plant in North Carolina, and so with a new manufacturing plant, you have a high scrappage rate of parts, and that's even more so with batteries. In order for us to reduce that scrappage rate if we can ensure that all the team members within that manufacturing plant have as much knowledge as possible on how to triage and calibrate various problems. We enable higher efficiency and reduce scrappage. And so that's the fundamental premise of Battery Brain, is to reduce battery scrappage on the manufacturing line. So it's a very similar architecture and a very similar application as GearPal. It's a chatbot that allows us to ask questions about a certain process, not necessarily machine. It could be a machine like GearPal, but it could be something like, I noticed that testing for my cathode did not meet optimal results. How do I fix this? Or what could be wrong, right? Do I need to look at material properties? The goal with Battery Brain is not necessarily to give the right answer, but it's to give the user an idea of what they should check in order to get to the right answer. So basically, did you check your material properties? Did you check the machine was calibrated? When you're checking all of these results and giving them a flight checklist, if you will, to allow them to better triage the problem, which helps us quite a bit in our RAG, to be honest. One of the most difficult things about Battery Brain was being able to augment it with internet search results. So the business unit that gave us the requirements for this product asked us to incorporate state-of-the-art battery knowledge within our responses. And in order to do that, we had to basically go to trusted sites on battery manufacturing or battery technology, solid state, liquid electrolyte batteries, et cetera, and incorporate that into our search results, which created some problems in its own. But what we did is we effectively, we follow a process similar to the following. So if a user asks a question and we can't find the correct results within the data that we've been given, we use the cosine similarity as a threshold. So if the threshold or cosine similarity is below a certain threshold, we go to the internet and we go to a select series of sites to try to find the answer. And then if that comes back positive, then we produce that response to the user and let them know, hey, couldn't find anything in the data, or in the documents, but we did find something online for you. And being able to give this hybrid search was something that took a while to balance and correlate, especially because we are dealing with a lot of different data similar to GearPal. One of the additional complexities of Battery Brain is that we had a lot of OneNote documents, Microsoft OneNote, because the trainings that Toyota ensued in order to dissimulate battery manufacturing knowledge, all the users took notes in Microsoft OneNote. And if you're familiar with that, it's a huge pain in the neck, because there are a lot of different things you can put in OneNote. Everyone's subject to their own note-taking styles. There's handwriting, there's shorthand for different vocabulary. There are different acronyms that people use without defining them. There are images with captions, images without captions. And so it becomes kind of it's a very difficult thing to standardize and ingest. And so we had to get a little bit creative, again, at ingestion, trying to make sure that we have this data-agnostic ingestion pipeline that also could draw some inference in context when it encounters a document that's not well structured. So one of the learnings from Battery Brain and GearPal together, we were able to use this common RAG framework, this common RAG pipeline, which allowed us to basically co-develop the applications together up to a point where they needed to diverge because they're growing separate features. But it allowed us to reuse a lot of code and really strengthen this data-agnostic pipeline or ingestion process that we're able to reuse in other applications, which my colleague Steven just alluded to a moment ago. In addition, we're able to, with the large language model, we're able to incorporate Toyota production standards, which, if you're familiar with the way Toyota produces vehicles, they do so in a very specific way. So it allows us to produce an additional level of quality control. The feedback mechanism that we use with GearPal, we also use with Battery Brain to establish those golden queries. And we're able to just make sense of a lot more data a lot faster. So I'd say, building these two applications together allowed us to construct a foundation for which we're able to springboard off of for other generative AI applications in the future for the rest of our group within Toyota. Now, to talk about the next couple use cases, I will turn it over to my colleague, Paul.
Thank you. Please give it up to Cordell and my friends here. Awesome. Are you all ready for a quiz? All right. So mainframe modernization, it's probably the most interesting project that I worked on at Toyota. Why is that? Primarily because it seems like it's a simple problem. You take one type of code and you convert it to another type of code. Seems simple, right? Well, let's think about what mainframe is. Mainframe is a system, it's a shared system, where you run a lot of programs. Each program is an application. The way how applications communicate to each other, they do that via ports. So you actually have network connections running between them. If you now, in the modern application architecture, you have your APIs, right? So you have your web servers, you have your endpoints. So somehow you have to bridge the gap between the network connectivity and going into the application layer and play in there. So years ago, someone decided within Toyota to hire a hyperscaler, not AWS, and to do exactly that. Take code in mainframe and convert that code into a modern language such as Java. It failed. Why? So imagine you have multiple departments within Toyota all working within the same shared environment. And you have to have a faith that whoever that person is, a consulting company or a provider or a vendor, will take that code, convert it, and you will be able to hot swap it between a system that was running on mainframe into the cloud in such a way that it doesn't impact production. Because the truth is, any downstream system impact may stop production of vehicles, which may have direct impact on the business. So this use case is a success story of partnerships. Partnership between AWS and Toyota, partnership between internal Toyota teams, for example, vehicle supply chain team who was heavily involved in this project. But it also is a partnership between human and AI. Let's take a look. So that's quiz coming. If you have ever read a book, Hugging Face Transformers, you get introduced to this term pipeline. And a pipeline could be text summarization, text generation. So first question, what is this pipeline? Well, the answer is text classification. How many people in the audience can say what this code is? Whether it's COBOL, RPG, or GCL? By raise of hands. Not that many. Well, so luckily we have Amazon Q with its capabilities that is able to understand the code written in COBOL and derive rules. So it's very good. It became very good at figuring out what is the rule set, what is the business rules that apply to a specific program. It is important because modern code conversion requires going through two-step process. First step is you take code and you convert it to text in order to be able to reason over the text. For example, to be able to say which parts of a program are data consumers, which part of a program are data providers, what are the variables, which tables, databases, what are the entities within the code. Having that, you will have trust in understanding whether the AI is able to convert the code into text that you as a human will be able to read and validate. That's a huge advantage. So this is a source code analysis with generative AI and knowledge graphs. These 3 pages are the output, the original output of our collaboration with AWS, where you have high-level overview of what the program is, the business logic and functionality, and then the data flow associated with it. The reason I picked this slide and to show you is there is a simple word in that slide. And the word is, or rather abbreviation is SSN. For many of you, you will infer that as social security numbers. But obviously in vehicle production, SSN means something different. In fact, there is probably north of 5,000 different abbreviations that exist within Toyota. And whatever system performs that code conversion has to be aware of those. When working with AWS, you get a front seat to the interaction between the teams, the frontline teams, as well as service teams. And I firsthand saw the back end of Amazon Q as it relates to code conversion. And what I saw for myself was a knowledge graph, a system that is well understood, that was useful, and created a sense of trust in me that this will actually works. The human feedback loops were essential in the success of this project. Why? Because first time it generated it, it maybe was accurate about 80%. By the time we finished and we went through multiple iterations, it was north of 90% accurate in terms of how it was converting from COBOL to text. First of all, the system that was built to analyze our code, COBOL code, does not have institutional knowledge. And that's what humans provide. Generative AI is an assistive technology. It doesn't replace a human. Also, no one is willing to make a bet that the system does it perfectly and blindly accept the outcomes of a generative AI system. So it's utmost important to provide the tools to people to be able to validate the outcomes, do it fast, reliable, and easy. So the vehicle supply chain team engaged, and they provided accuracy assessment with their contextual understanding of the problem. And it allowed us to figure out what are the dependencies that exist in the migration and identify islands which could be migrated without the risk to Toyota production. It also allowed us to understand the complexities and size of each of the programs within the program set and thoroughly understand the business impact. At the end, Amazon team was able to provide to us with a UI where we could load our COBOL programs, and it would generate for you the data flows, the entities, the databases, all of that available to us to download, validate, and use. Now, let me tell you about the future. We think about AI in terms of time. That's one of the approaches. So some tasks, they take 5 seconds. Other tasks, they take 5 minutes. And others take 5 hours. Let me tell you that generative AI is pretty good at 5 seconds to 5 minutes task. What about 5-hour tasks? And the future, as we see it, lies in reasoning engines and the application of formal logic on both inputs and outputs of LLM. Today, Toyota invests in AI on the consumer side as well as an enterprise side. Many of you in the audience are owners of Toyota and Lexus. Hopefully, you will be our future customers. And with us, you will be building the future of mobility for all. Thank you.
Thank you for coming. Please do fill out the survey. It helps us improve our presentations and overall content.